All right, welcome, ladies and gentlemen. I'm doing another live stream, and this is a little off the cuff because I wanted to just make sure I went through our second quiz before my students were taking their test, and I also wanted to attempt to go ahead and work on the new YouTube kind of live dashboard, and it's been a lot of trial and error for me, and everything for my stream just does not seem to be working right. So I'm not even sure how the stream is being presented as far as the chat or where it's at. I cannot figure out everything on my own. So, either way, whatever, at least I have a recording and I can upload that for my students. So, I'll just go ahead and work through this, assuming that the stream is working good, as I have a, let's see, that doesn't even show me a good stream length on that. That's so weird. So I guess I'll just go and check on the last stream, and it says live. But when I look at the dashboard on the new dashboard, there's no way for me to check. So it's really weird. I'm really having a hard time with this new dashboard. And of course, they're going to put the old one away. So therefore, the one that I'm used to and familiar with and can understand things is going away. So, all right. So now it shows I'm live, at least on the old dashboard. I'm not sure why the new one's not working, but either way. So, all right, let's actually, you know what? I'll check in because I think I did disable my chat unless you have a member, but let me take out the pop-out chat just in case I have anybody else that chimes in. All right, sweet. Okay, so anyways, guys, this is not my Q&A, my typical Q&A kind of live stream. That's going to absolutely be happening, though, in the next couple of days. So I will put out a notification for you guys, and therefore you guys can submit some questions to me, and I'll be more than happy to go over them. I decided to do a live stream because last year I did live streams over the quizzes, and I just feel like it's a kind of good idea. I just don't have time to be doing the Q&A kind of portion, but I just kind of feel like a live stream, it's like when I have time, it's kind of fun just to kind of do it rather than just a video. Just kind of the old stream way. But I did kind of open this also for as far as the chat on people that are, members as well. Therefore, they could obviously go ahead and reach out to chat. And if there's, any kind of further questions or anything like that, you guys can obviously comment down below and I'll be more than happy to answer your questions. So let's see here. We have given the factor, find the remaining zeros of the polynomial by writing the linear factorization. So this is the second quiz in our polynomials unit as we're taking the chapter test next week. And then we're done with quarter one. So I'm not sure where you guys are with your class, but we're going to be wrapping up functions and polynomials for quarter one and then getting on to trigonometry. So it says find all of the remaining polynomials. All right, so remember when we're given a factor, typically I advise my students to go ahead and use long division because even though you could use synthetic division with the zeros, I don't really teach that method anymore because I noticed when teaching that method, most students would just get the problem wrong anyways because it was just a little bit too much algebra, too many steps for them to remember. So I just advise them, if you have a factor and as long as the factor does not produce a integer zero, then just go ahead and use long division. All right, so by using long division, we have x squared equals x to the fourth. Now I taught my students kind of two ways to look at this. One, you could look at this using the rules of exponents. Like how many times does x squared divide into x to the fourth? Hopefully you recognize that's x squared, not 2 times. But you can always verify your answer because when you take your first term and quotient, you multiply by both terms in the divisor. So that gives you x squared, and that gives you a 5x squared. I'm sorry, that doesn't give you 5x or x squared. That gives you x to the fourth, right? X squared times x squared is x to the fourth. And again, that's really important because you're always going to get the exact same term. When you divide x squared into x to the fourth, whatever answer you get, when you multiply those two back, you better get the exact same value. The other thing that's important about this problem is that I put the 5x squared under the 8x squared. I didn't put it under the 4x cubed because they're not like terms, right? Now, we don't really need to subtract everything. We can just subtract these two rows. There's nothing really to subtract a 4x cubed from, so you could put a 0x cubed if you wanted to, or you could just bring it down. 8x squared minus 5x squared is going to be a positive 3x squared. And then you could subtract these from 0 or just bring them down, whatever, kind of makes you feel good. Then that was kind of like one round. Now we just do it again. X squared divides into 4x cubed. Again, how many times does x squared divide into 4x cubed? Well, that's going to be a positive 4x times. And then you do 4x times 4x squared, which is a 4x cubed, and 4x times 5 is going to be a positive 20x. Again, subtract the rows here, And then 3x squared, you're subtracting really from nothing. That goes to 0, and then you're left with a positive 15. And then you could say x squared divides into a 3x squared, and that's going to be a positive 3 times. 3 times x squared is a 3x squared. 3 times 5 is a positive 15. Okay, and then you subtract. And obviously you're going to get a remainder of 0, which we know, right? Because it says this is a factor. But the question was, given the factor, find all the remaining zeros of the polynomial by writing the factor. So it's very, very important that we understand if this polynomial divides into this polynomial that many times, then we can write the polynomial as, x squared plus 5 times x squared plus 4x plus 3. Right? If, the example that I gave to my students was, if 4 divides into 12 3 times, then, 4 times 3 equals 12. And it's really the same idea, it's just with polynomials. So now we got to go ahead and simplify this down. Now, some students might have had trouble, factoring that down. So again, we could, if we're trying to find the zeros, right, we could set this equal to 0. And therefore, we could apply the, linear factorization. If you have x squared plus 5 times x squared plus 4x plus 1, or plus 3, I'm sorry, you can now set them equal to 0 and go ahead and solve. Hopefully, you could also factor them. But here we have a quadratic, so you could subtract 5 on both sides. So you got x squared equals negative 5. And then when you introduce the square root, remember you have to do plus and minus. And remember, we can't take the square root of negative 5 under the real number system. However, we can go ahead and introduce the complex number system, which is I plus or minus the square root of 5. This can be factored into x plus 3 times x plus 1. So therefore, x equals negative 3 and x equals negative 1. So those were the zeros. But I also said not only find the remaining zeros, but also find the linear factorization. Well, the linear factorization is just everything written as a product of its linear factors. So here I have a product of 2 quadratic factors, and you can always write the factors, your factors, or as from your zeros. So what I'm going to do is I'm just going to take my zeros and just break this down in factoring, basically using difference of 2 squares. X plus I square root of 5 times x minus I square root of 5. And this turns out to be x plus 3 times x plus 1. And there you go. That is your linear factorization as well as the zeros. All right. The next one was using Descartes' rule of signs and the fundamental theorem of algebra to determine the number of possible real positive, real negative, and complex zeros. And as I've been speaking with my students, one of the main issues that I know that a lot of my students have is understanding where we're talking about possible zeros here. They're not giving you exactly what the zeros are. It's just giving you a possibility. So to determine the real possible positive real zeros, we're just going to find the number of sign changes. So we did 1 sign change, 2 sign change, 3 sign changes. So we're going to say real positive is just the number of sign changes minus an even number. So it's going to be 3 or 1. And again, Descartes' rule of signs does not tell us exactly how many zeros there are. It just tells us what is possible. And again, we're subtracting an even number because, basically complex numbers, which is another subset, always come in conjugate pairs, the positive and negative. So they always comes in 2s. So that's why we're always going to be subtracting an even number. So it's 3 or 1. Then to go ahead and determine the real negative, we need to be able to figure out what g of negative x is. So basically we're going to plug in negative x into our function, and then we're going to count basically the sign changes from there. So first of all, we just need to remember that anytime you have a negative x raised to an even power, that's going to make it positive. And anytime you have a negative x raised to an odd power, that's going to make it negative. All right, so this becomes a negative x to the 5th. This becomes a positive, but it's being multiplied by a negative, so therefore it remains negative. This turns into a negative multiplied by a positive, so that's a negative. That becomes a positive. This becomes a positive. And that becomes a negative. All right, so we can see here that the number of sign changes here is 1 and 2. So we could say the number of real negative is 2 or 0, because again, we always have to subtract an even number. So now comes into our idea of the fundamental theorem of algebra and determining the number of complex zeros. Remember, the number of complex zeros has to be 7. Has to be. That's the fundamental theorem of algebra. I'm sorry, not 7. That was another example I was doing today. It has to be 5, right? So what we have to do is we have to go through all of the possibilities, or sometimes I just refer to them as options, right? You could have 3 positive, or you could have 1 positive. We don't know. This is just what is possible. You could have 2 negative or 0 negative. We don't know. It's just what is possible. So let's kind of just represent some options, because for our options, we want to figure out, well, what are the options for complex zeros? Like, what are the possibilities, right? So for complex, let's just kind of do a couple options. Option number 1. Option number 1 means that we have 3 positive and, let's see, 3 positive and 2 negative. Well, if we have 3 positive and 2 negative, that's already 5 zeros. So therefore, there's going to be 0 complex, right? So I'm going to use 0C as complex. So one option for complex is just having 0. We could have option number 2. Option number 2 would be 3 positive and 0 negative. Well, if we have 3 positive and 0 negative, remember we have to have 5 zeros. So therefore we have to have 2 complex. Option 3. And again, these are just options. We have no idea. Descartes' rule of signs does not tell us what is the correct one. It just tells us what is possible. Option number 3 would be we have 1 real positive and we have 2 negative. So then you say, okay, so 1 positive and then you have 2 negative. And again, that's going to give us 3, so therefore we have to have 2 complex. That is redundant, so I'm not going to do that again. But then we go to our last example, which is option number 4, which would be 1 positive, because you have to have 1, right? And 0. I'm sorry, wait a minute, what happened here? Yeah, and 0 negative, and therefore we'd have to have 4 complex. So the number of possible complex is going to be 0, 4, 0, 2, or 4. All right, for question number 3, we're going to determine all of the zeros. So I have, in this case, I have h of x. Oh, crap, I forgot to turn in my charger. Dang it, I always do this. All right, I'll be right back. I'm going to plug in my charger. All right. You would think after doing this so many times that I'd be a little bit better at that, but sometimes, whatever, just gets in front of me. So, all right, let's go ahead and continue. So determine all the zeros. So basically all we're doing is just trying to find all of the zeros. And so the main thing I was looking for is, obviously to understand for the definition of finding the zeros is when the equation, what values of x make the equation equal to 0. At least x is for our variable here. I'm going to write this in standard form. Say negative x to the 4th plus 2x squared plus 8. All right. Now, I recognize this is a trinomial, and I can also recognize that this looks very similar to something I could factor. I don't really like factoring when a negative is in front, so I'm going to factor out that negative. Okay, starting negative x to the 4th. So that becomes a minus 2x squared minus 8. All right, great. Now, again, I still don't like really factoring when it's raised to the 4th power. So I'm just going to do a factoring problem that I know how to do. I know that if it's squared, I would know how to factor this, or at least I would know if it's factorable or not. So I'm just going to write the quadratic form here real quick, and then I'll explain why this is sometimes helpful when you get stuck. So, from the quadratic form, something I've been doing since Algebra 1 and Algebra 2, what two numbers multiply to give me negative 8, add to give me negative 2? Well, that's going to be x minus 4 times x plus 2, right? So the important thing that I want you to understand is look at this equation and look at that equation. They're really or expression. They're really the exact same expression. The only difference is the powers, right? So we know that if a trinomial is going to be broken down into a product of two binomials, right? All like trinomials, if they're factorable, is going to be broken down into a product of two binomials. The numbers are not going to be the same. Like we're not going to use y's now, right? We're not going to use like the factors 8 and 1. Like the numbers are still the same. That's not going to change. The only thing that needs to change is instead of multiplying x times x to give us x squared, we need x times x to give us x to the fourth. Instead of negative 4x plus 2x to give us negative 2x, we need them to give us negative 2x squared. And one thing that I kind of taught, I don't really like, giving like tricks like this with no really explanation, but you can really kind of take whatever the middle term, that's going to be the power of the factor. Since this is squared, you can see that's going to be the power of the factor. Because again, it makes sense. X squared times x squared, you add powers when you multiply exponents, right? Is x to the fourth. Your like terms now combine as far as an x squared, and you can see negative 4 times 2 is negative 4 times positive 2 is a negative 8. Well, now we can go ahead and apply the zero product property. This negative is not impacting the graph. Remember, the negative is just reflecting the graph across the y-axis. So it's not impacting the zeros at all. So I can just divide that out if I want to, right? It's still there. Don't want to forget about it. Especially if you're graphing or writing the linear factorization, it's important, but it doesn't impact the zeros. So because it's just a reflection, that's all it is. So I'm going to set these both equal to 0. Because I had a lot of students that were making mistakes using the zero product property. So in this case, I get x squared equal to 4. Here I get x squared is equal to negative 2. So again, most students got, you can take the square root unless they forgot the plus or minus. And then here, you're taking the square root of a negative 2. Well, you can't take the square root of a negative number, nor can you take the square root of 2. So therefore, in this one, we need to involve our complex number system. Oops, let's use the plus or minus in front of that. I squared root of 2. So the zeros are just going to be right in there, okay? For the next example was the factoring by grouping. Basically, I taught my students, when you see 4 terms, think factoring by grouping. Just automatically think factoring by grouping. But I told them, though, be careful because we don't want to write something like this because you're not just grouping the first 2 terms, second terms, because then you just wrote a multiplication problem. So don't do that. Same respect, don't do this because this says negative times 10x and negative times a positive 30x, which is also not the same thing. So just be careful when you're grouping them. Delete a little more, is to just make sure when you write your grouping symbols that you include them around the proper terms. So I'm going to set it equal to 0 because I'm finding the zeros. So I have 2x to the fourth plus 6x cubed, group, subtract. And what I'm going to do here is I'm going to change the sign of the 30x. And again, that makes sense though, because if I distributed this negative, that'd give me a negative 10x squared and give me a negative 30x, right? So now when we use grouping, the way that we do grouping is we factor out the GCF. So you graph out the greatest common factor of each of these. Here you can see that I have a 2x cubed I can factor out. That's going to leave me with a x plus 3. Here I can factor out a negative 10x. And that leaves me with a x plus 3. No. If I factor out a negative, that's going to be a minus. So what happened here? So I factor out a negative. So I want to factor out a positive 10. That's right. Yeah, it's already a minus. So if I factor out a positive 10, that'd be a 10 x plus 3. Very good. Okay, because I factor out a positive 10. Perfect. Now you can see that both these expressions have an x plus 3 in common. So I'll factor that out. And then I'm left with a 2x cubed minus 10x. Now from here, you could go ahead and use the zero product property again, but I recognize I can factor out some common factors again, so I'm just going to work a little bit further here. I'm going to factor out a 2x out of this expression, and that's going to leave me with a x squared minus 5 times an x plus 3. Now, to do a little bit quicker, rather than using the zero product property, which you could do at this point, I'm going to go ahead and just write the linear factorization. So I have 2x. I'm going to factor this. So it says x squared minus 5 equals 0. So therefore, x squared is equal to 5. Therefore, take the square root of both sides. X is equal to plus or minus the square root of 5. right? And I could write that in factored form as x minus square root of 5 times x plus the square root of 5 times x plus 3. So there, now that I've written the linear factorization, something I taught in class, then it's a little bit easier to go ahead and write the zeros here, plus or minus 5 times negative 3. Okay, and that is what the answers I was looking for in that question. All right, moving on to next one, which is writing the equation of the polynomial in standard form when given the following zeros. So really the main idea that we want to practice with this is understanding if I give you the zeros in set notation that you can write them equal to x. So 2 square root of 2. But not only that, but then also understand that the conjugates exist for complex as well as for irrational numbers. So if x equals 2 square root of 2 is a 0, then x equals negative 2 square root of 2 also has to exist. And then we have x equals negative 1/2 with the multiplicity is equal to 2, which I'll come back to later. Now again, so this is just another way we represent zeros. And if we want to understand the factors, what we can do is we can just set them equal to 0 to get the factored form. So x plus 2 square root of 2 equals 0. Now the key important thing here is I still have a lot of students making the mistake of adding 1/2. But nobody really wants to do multiplication with fractions and then change the answer. So what I taught students was to multiply by 2 and then add the 1. Because if you have 2x plus 1 equal to 0 and you solve for that, you're going to get x equals negative 1/2, right? I just multiplied by 2 and added 1. But this is a lot easier to be multiplying than with fractions. So now I have my factors equal to 0, and now I just want to write my factored form. So I'm going to set it equal to f of x times x minus 2 square root of 2 times x plus 2 square root of 2 times 2x plus 1. But remember, the multiplicity was equal to 2, so I need to raise that to the second power. Now, a lot of students don't have the patterns kind of down from this, but that's why it's really important to understand your difference of two squares, I think was important, as well as understanding your perfect square trinomials. Because if you got those down pat, then this is multiplication is rather simple. So x times x is x squared. And obviously you can multiply this out using FOIL, if you box method, whatever. But my preferred method is just understanding, negative 2 times negative 2 is negative 4. Square root of 2 times square root of 2 is square root of 4, right? And then just simplify it. And you can really, you should recognize it by difference of two squares, but hopefully you recognize the square root of 4 is 2, and therefore that's going to give you negative 8. And then the 2x plus 1, remember, is 2x plus 1 times 2x plus 1. So that's a difference of two squares, which gives us x squared minus 8. And then this is going to give you a 4x squared plus 4x plus 1. So just make sure this is not 4x squared plus 1 squared, right? Don't do that. Make sure you expand that out. Now you could either use box method, you could use distributive property. I'm going to go ahead and just multiply it out over here using like the vertical method. So x squared times 4x squared is going to be a 4x to the 4th. X squared times 4x is going to be a positive 4x cubed. X squared times 1 is going to be an x squared. And then I can just add that. This is like my side work here. Negative 8 times 4x squared is going to be a negative 32x squared. Negative 8 times 4x is going to be a negative 32x. And negative 8 times 1 is going to be a negative 8. So those are my like terms. I'm just going to add vertically to give me 4x to the 4th plus 4x cubed minus 31x squared minus 32x minus 8. Okay, so that is my polynomial, right? So that is like the factored form. I just kind of did distributive property, but there's a couple other ways you could have done that. 4x to the 4th plus 4x cubed minus 31x squared minus 32x minus 8. All right. So now we kind of get into the multiple choice portion. And for the multiple choice portion, I'm not going to work through all of them because, I give my students 60 minutes to complete this quiz. And for the beginning, for these first 4 questions, I tell students, show me your work. Make sure I can see exactly what you're doing. I grade these pretty specifically. If you're missing out some notation, I mark them down. On the multiple choice though, I say, hey, we got to like learn the tricks of the trade, right? You don't need to do every single problem. Do as much work as you need to be able to figure out the answer. And obviously maybe you guys have some different ideas. I'm just going to work through the ones that I saw as far as the work that I need to show. But it was really nice to see how some students did work differently than others and were able to come across their answer. So I basically just asked them to show me some work, how they arrived at the answer. And as long as I could justify the work that they're doing made sense, then they would get credit for, partial credit for at least the answer. All right, so it says, first one says, find the polynomial p of x of degree 3 with integer coefficients 3 plus 2i. All right, so if we know 2i exists, then we know negative 2i has to exist. All right. Let's see here. Now, so therefore I can write the zeros as x minus 3, or the factors, I'm sorry, x minus 3, x minus 2i, and x plus 2i. All right. Well, obviously, I know those are never going to multiply to give me a positive 3x in front, right? So don't need to worry about that one. And then hopefully you recognize that this is going to come from x squared plus 4. So x minus 3, if you were to multiply that out, difference of two squares, again, I cannot stress it enough, x squared plus 4. And if you were to solve x squared plus 4 equal to 0, you would get those two zeros into factored form. Now, my key point here is I recognize if I were to multiply negative 3 times 4, that's going to give me a negative 12. The only answer that has a negative 12 is E. So I'm just going to stop there. Like, why go through the multiplication of everything if I recognize the only difference between these equations was the last term? I'm just going to figure out what the last term would be, which would be the constant times the constant. The next one says, find all the zeros of the polynomial 2x cubed minus 9x squared minus 6x plus 40, given the factor x plus 2. I actually didn't even look at this one as far as being 2. If you factor out a 3, no, that doesn't work. Okay, never mind. So it's not factorable. So I'm just going to use I have a factor, but I don't want to use long division. I'm going to use synthetic division. So I'm just going to take 2, negative 9, negative 6, and 40. So I bring that 2. 2 times negative 2 is negative 4. That becomes a negative 13. That becomes a positive 26. Positive 20. That becomes a negative 40. 0. Okay, so now if x plus 2 is a factor, that means it's a factor. Again, that's the remainder, constant, linear, quadratic. So now I basically need to figure out, that means this is also a factor. I just need to figure out what is the factored form of that. Jeez. Okay, so, and obviously we can see like the 5 and the 2. So therefore, I know the factored form is going to be 2 and 2x and an x. And it's going to give me two terms that's going to multiply to give me 20. So I'm just trying to think what two numbers multiply to give me 20, add to give me 13. But with that 2 here, so one of the factors is going to be multiplied by a 2. And I know I have a 5 here. So therefore, I could do a 4 and a 5. Why did I do it? I did this and I didn't have a problem with that. So what is going on here? That's a 2x minus 13. Now it's like jumping. 8 and 5. That's it. So if I had this to be a plus 4, and that to be a, no, sorry, not plus 4. It needs to be a minus 4. And then 4 positive 5. Okay, because again, 2x times x is 2x squared. 5 times negative 4 is going to be a negative 20. So that doesn't work. Why does that not work? Oh, they both need to be negative. Jeez. Okay. Yeah. So 2x times x is 2x squared. Negative 5 times negative 4 is positive 20. That's a negative 5x. That's a negative 8x. Negative 5x plus negative x, 8x is negative 13. If you were to set this equal to 0, you would get x equals 5 halves. And then if you were to set this one as equal to 0, you get x is equal to 4. So we already know x equals negative 2 is a 0, right? X equals negative 2, so that one couldn't have been the answer. And therefore, we know that one's going to work. Now, the next one, I love this next one because a lot of students were struggling to show some work, and I really appreciate them showing work. But it's a great idea of understanding the fundamental theorem of algebra. We know x plus 3 is a 0. Therefore, x equals -3 is a 0, right? So that is not the answer, and that's not the answer. So you only have two options. However, based on the fundamental theorem of algebra, there has to be 3 zeros. Right? The fundamental theorem of algebra says there has to be 3 zeros. Doesn't matter if they're real or complex or anything. So therefore, it just says find all the zeros. So therefore, we could like do synthetic division and then use the quadratic formula and figure everything out if we needed to. But again, based on the fundamental theorem of algebra, we know there has to be 3 zeros. So therefore, B is going to be our answer. Number 8, it says find the polynomial of the lowest degree with only real coefficients that having the given zeros of 2i plus 4. So again, this one's very similar to like the last example. We could multiply everything out if we wanted to, but I don't think it's really necessary. So what I showed my students in this class was to use kind of some shortcuts. And if they wanted to use the box method to multiply everything, they could. But given these zeros, I know that 2 minus I has to exist. All right, so those are the zeros. And if I know the zeros, then I can figure out the factors. All right. Now, what I showed my students was that, when you're multiplying these, you could also look at this as in terms of the difference of two squares. So you could group the first two terms, plus I, and you could group the last two terms. The first two terms of the other polynomial. The reason why this was beneficial is because if you were to multiply this out, right, you would get a x minus 2 squared plus minus an I squared times x minus 4. Now, when you expand x minus 2 squared, you get x squared minus 4x plus 4. This becomes plus 1, times x minus 4. And then rather than doing the rest of this, look what happens here. If I was going to look at the only difference between the last two terms, right? If I was going to multiply 5 times -4, 5 times -4 equals -20. The only answer that has a -20 here is answer A. So of course you could multiply that out like I did in the free response. But again, I'm just asking to look for the closed term. And a lot of this you could have done in your head, but I wanted to show it to you. So therefore, those of you that were not following along could go ahead and see me from there. The last one was just the rational zero test. And that was basically, determining the values that are possible rational zeros. We have no idea without, looking at this, without testing the zeros or, seeing what they are via graph is, what the possible rational zeros are. So all the rational zero tests tells you if you have a real rational zero, it's going to come from this list. And basically what we taught is it's going to be the factors of P over the factors of Q plus or minus. So plus or minus the factors of P over Q. So P represents the constant and Q represents the leading coefficient. So you could use P over Q, or you could do the constant over the coefficient. It's just sometimes easier, I think, to memorize like P and Q. So let's list out the factors of 2. So the factors of 2 are 2 and 1. The factors of 6 are going to be 6, 3, 2, and 1. So basically, all I'm going to do is figure out all those combinations, all right? So I have plus or minus. I'm writing the plus or minus outside parentheses because I don't want to write plus or minus for every term. So that's going to be 2 over 6, 2 over 3, 2 over 2, 2 over 1, 1 over 6, 1 over 3, 1 over 2, 1 over 1. Now, I could go ahead and like simplify these, but again, like my main idea is finding like a fraction that's not in one of them, that's maybe in all of them. Like for instance, 2/3. So 2/3 in this one, it's not in this one, it's not in that one. All right, great. So then what is the difference between these two? Where these differ by 3. Is 3 in this subset? No, 3 is never in this, right? Because you only have the numerators are 2 and 1. So therefore the answer is B. So you could simplify it, but a lot of times I want you to practice with these, multiple choice is looking for those kind of tricks so you don't have to solve the whole problem. So there you go, ladies and gentlemen. That is the second quiz in polynomials. After we took the first quiz, I hope that you, or especially my students, are ready for their test on polynomials. I hope you guys enjoyed, and I'll see you on the next live stream. For those of you that are looking for the Q&A, that will be coming up this upcoming Sunday. So now I just got to remember how to close out. All right. Cheers. Oh, that didn't work.